Okay, let's look at this question here, which is we took probability and PNC. So we are told to find the probability of these 5 digits, okay, with no repeats, right? That the number is greater than 30,000. I think the first thing to understand is that what we need to do is divide by the number of non-restriction, right? The number way to arrange it without any restriction. So that will be 5 factorial. Okay, so this one, simply put it, if we have 5 slots here, the way is 5, 4, 3, 2, 1. Okay, so that's that. But the number greater than 30,000 would then be actually we just need to find, so required probability. Okay, find the number of ways that you need. So there'll be 1, 2, 3, 4, 5. If the number is greater than 30,000, meaning to say we can put 3, 4, or 5 here. Okay, so we have 3 options here. So it's 3, then after which this is 4 times 3 times 2 times 1. So there will be 3 times 4 factorial. It's not an issue, right? So the required probability in this case would be, we just take 3 times 4 factorial, okay? Because after picking one for this guy, you will have 4 more options left. So say you put 3 here, you have 1, 2, 3, 4 here. Okay, then if you put 2 here, then it will be 4 as well. So there we go. So the answer will be 3 over 5. Okay, so 3 over 5, that will be 3 over 5. Great. So let's look at part 2. The last 2 digits are both even. So the last 2 digits are both even. What we need to know is how many even numbers are there, digits are there. So we have the numbers 2 and 4, right? There are only 2 options here. So these 2 were reserved for even numbers. You can just think of this as 2 choose 2, but you technically don't really have a choice here because you have 2 even numbers. So you can just put 2 times 1 here. Okay, so it's 2 factorial because you put 2 if you put 4 here, then you have 2, then if you 2 here is 4. So this is 2 factorial over here. The front will be 3 factorial, right? Because the odd digits will be the first 3 numbers. Okay, so that's that. So the required number of ways would be 3 factorial times 2 factorial. Okay, so the required probability would then be 3 factorial times 2 factorial over 5 factorial. That will be 1 in 10. That's it. Okay, so not an issue. So we look at the subsequent, which is part 3. The number is greater than 30,000 and odd. Okay, and odd. Okay, this is a bit tricky because it's sort of like dependent, right? It may not be so obvious that you need to do case by case, but we try and understand first. So 1, 2, 3, 4, 5. This odd number that we need, this would have like 1, 3, and 5. Okay, but the case now is that the number has to be greater than 30,000. So meaning to say this will be 3, 3, 4, and 5. Okay, but therein lies the problem. Okay, because if I were to choose 3 here, then I will have 2 options to choose from. Okay, but if I were to choose 1 here, then I got 3 options. You see that there's dependent. So basically you need to split the cases. It may not be so clear, but if let's say if I choose 5, the digits 5 here, then after which I got 2 options as well. So essentially the last digit being 3 and 5 will affect the number of choices you have to put for the first guy, because the first guy had to be greater or at least 3. Okay, that's the case there. So you break down the cases. So if the last digit is 1, I know that for the first 1, 2, 3, 4, 5, I will have 1 option here. Then this I have 3 option. After putting 3 option here, I will left with 3 numbers, right? 3 digits, 3 times 2 times 1. So that's that. This will give us 18. Okay, so case number 2 is the last digit is 3 or 5. Then now we think about this guy, 1, 2, 3, 4, 5. So this will be 2 options, so it will be 3 or 5. But once you done this, will be either 4 something. Okay, whatever is not. So there are 2 options for the first number here, first digit. This one depends what is chosen for behind. So if you choose 3 for the behind, then this will be 5. Okay, if you were to choose 5, then this will be 3. That's the idea. Okay, so basically you have 2 options here, then this will be 3, 2, 1 as well. Okay, so this is the number of ways you can focus to. There's 24. So what we're going to do is hence number of ways will be, total number of ways will be 18 plus 24, which is actually 42. So the required probability, we just divide by 5 factorial. That's it. That will be 7 in 20. Okay, so that's how I do this question here, proficiently.